All right, so let's begin. So last time I started this relative frequency histogram. Uh, okay, so the idea was let me do that once more today. Okay. The relative frequency. Okay, so actually I wrote it here is obtained by dividing the frequencies by the data set size, right? Okay. Now, after the class, I realized that I ran this command in Python, which was um, like plt.hist. Then I put the data here, the beans size here, and I said density is equal to true. This command actually doesn't give you the relative frequency histogram. It returns something called the estimate of a probability density function, which is not what we're talking about here. So how do you actually plot a relative frequency histogram in, let's say, I want to demonstrate that in Python, right? Um, so suppose we have this data. So let's recall from the previous stage class. Okay. All right. Excuse me. So I need to put it as an array. So let's input that in Python. So we have this data. Now, what would you like to do? So we, if we do the histogram simply, right? So if you do the histogram, okay. So before that, I need to import the plot thing. So this will return me some sort of histogram. And this picture was seen here actually. This was input last time. Okay. Now, if I want to do relative frequency histogram, so I have to first of all figure out the class intervals and the frequencies and the relative frequencies. Okay. So if you look at this output here, this output actually give me two extra arrays and then a picture. So what are these arrays? So let me store those some here. So let's define a variable, say like frequency. Okay, so let's store that somewhere. It still gives me the same picture, but you are not seeing these outputs because those outputs are stored in this variable frequency. If I call this variable frequency, you'll see this output. Okay, so let me copy this. and paste it here. So this is one array, and the second array is actually I wrote it in the reverse order. Okay, so what are these two? So the first one is basically the endpoints of the class intervals. Okay, and the second one is the frequency of each class. Okay, so essentially, if I try to draw a table here, so it's going to look like okay. Hmm. Um, um, okay, so here is the class, and here's the frequency. Okay, the classes are, so I'm not going to write everything, but classes are, these are the endpoints, right? So the first class is 1 to 2, second one is 2 to 3, third one is 3 to 4, and so on. And the number of data points inside each class is given by those numbers. So a number of data points between 1 to 2 is 1, and then 2 to 3 is 2. 3 to 4 is 3, right? And then 7, and then 12, right? And then 12, and so on. So these are the frequencies of class, of each class. Look at the histogram. So this is from 1 to 2, 2 to 3, 3 to 4, and it has the heights. Okay, anyway. So we have done this last time. Now to do relative frequency. So first, the relative frequency is given by. So basically, you have to divide each entry of this frequency array by the total number of data set, right? So how do you do that? Okay, now so let me write a comment here in Python. So this variable, that frequency that is stored here. Okay, so this contains two array of numbers. Okay, and how do I recall these arrays? Okay, to recall a specific array, we call by this variable, excuse me, which is frequency, and in the bracket you put the index. Okay. For example, if I write frequency 1, it is giving me, so if you notice very carefully, actually, frequency 1 is giving me the second array. Okay, so frequency 1 gives me the second array, and if I write frequency 2, it will give me error. Actually, frequency 0 gives me the first array. So this is because the indexing by default starts from 0. Starts from 0. Okay, so when you call the 0th element of of an array, you get actually the first element, and 1 is the second element, and so on. So anyway, the point is that so basically you see that this frequency 1, right? which is this second array. This is actually the class interface, right? So these are the end points of the class interface, and frequency 0 is the first array, is the frequencies of each class. Okay. Now notice one interesting thing. So if I look at the length of each array, so let's see. If I look at the length of this frequency is 0, right? I get 10. So that frequency 0 is the frequency. Like there are 10 classes, so I get 10. If I look at length of frequency 1, which is the second array, I get 11. Can anyone say why am I getting two different numbers? Because this frequency 1 is the endpoints of the interface, and frequency 0 is the class. So I have 10 classes, right? So I have 10 classes or 10 beans of this histogram. So this histogram is divided into 10 vertical lines. So frequency 0, which is the frequencies, gives me there 10 frequencies. But for the other one, why am I getting 11 data points? Are you following me? Okay, so let me write this down. So 1 is the endpoints of the class interface, right? Is the endpoints of 10 class interface, right? Now, if you have 10 class interface, you need 11 endpoints, right? Which has 11 many endpoints. Because if I try to draw it, right? So what are the endpoints? So the endpoints are these, right? So these are the endpoints, which is 1, 2, 3, 4, and so on. Okay, so there are a few classes. So let's say like there are, how many classes are there? 1, 2, 3, 4, 5 classes, right? But how many endpoints are there? The endpoints are 1, 2, 3, 4, 5, 6, right? So if you have n many classes, there are n plus 1 many endpoints. Anyway, this is a subtle observation that I wanted to make. Okay, now the relative frequency, right? So relative frequency is that frequency array divided by the total number of things, right? So frequency 0 is the frequency. So now total frequency is sum of that, right? So sum of this array. So if I recall that 62. So I had 62 data points actually. Okay. All right. So the relative frequency, let's call it a new variable. It's going to be frequency divided by the total frequency. Okay, so if I call that, this is the array I get, which gives me the relative frequency. Okay. So let me write it here. Okay, so essentially by dividing each of these entries by 62. Okay, now we want to plot a histogram. We want to plot a histogram against the classes and this relative frequency, right? So, excuse me. plot a histogram. Or actually, actually it's called a bar plot with the relative frequency. So for that, we need two things. We need number A, the classes, right? And number B, the relative frequency. Okay, so now actually command here. What is that? That is if I give, I think. So let me see if it works. Select 1, 4, and give two other numbers. Select 1, 2, 1, 3. Okay, so it does something like this. If I give an array of numbers and second array of numbers, so at 1 it puts a height of 0.2. As you can see, at 1 it puts a height of 0.2, and at 4 it puts a height of 0.3. So at 4 it puts a height of 0.3. So we'd like to do the same thing, right? So we'd like to in the first array we will give the. So our goal is that like to pass two arrays, right? And the first array should be the midpoints of the class intervals, right? I don't know if you're following this. And the second array should be the relative frequencies. Right? So once you do this, you will get a bar plot like this. So if you pass two arrays, the first array is the midpoint of the class intervals, and second array is the relative frequencies. Okay, we already have the second array, which is stored in this one relative frequency. We would like to get the first array only, right? So we already have the relative frequency. Excuse me. For the second array, we need to construct the array of the midpoints of the classes. Okay. Now, how do we do this? There is a problem actually, because what are the classes? So frequency 1 is the endpoints of the class intervals. So from the endpoints of the class intervals, how do we get an array of midpoints of the class intervals, right? So if I call that frequency 1, right? So this variable, this array, which is frequency 1, is the end points of 10 class intervals. Actually, let me be more precise, is the 11 endpoints of 10 class intervals, right? From there, how do you calculate? So how do you figure out the midpoints? Okay, so let's look at the class size, right? So class size is going to be, if I look at this frequency 1, right? And frequency 1's, let's say like, second element minus frequency 1's 0th element. So class size is 1, right? Actually, this is kind of stupid. You'll know that class size is 1 because it is 1 to 2, which is 1, 2 to 3, difference is 1, 3 to 4, the difference is 1, 4 to 5, difference is 1, and so on. So we'd like to create an array which is like 1.5, 2.5, 3.5, 4.5, up to 10.5. Okay, obviously we can type it up. We can type 1.5, 2.5, 3.5, and so on. But for 10 classes, but if you have 100 classes, then it will be a pain, right? So what do we like to do? We want to shift, right? So remaining to use these techniques in your homework at some point of time. So you'd like to shift the whole array, this one, which is frequency 1 by the half interval, excuse me, half class interval, half class size, which is 0.5. So shift the whole array by 0.5, which means if I do this thing, right, frequency 1 plus 0.5, this will actually shift the whole array. It was 1, 2, 3, 4, 5, 6 up to 11. It's now 1.5 to 1.3. But it's stored, right? So if I call this frequency 1, you will see, okay, it is the same thing. So okay, so this is standard programming technique that you want to store it in the actual frequency 1. Actually, you know what? Let me call it different variable. So let's call that as like midpoints, all right? Midpoints are frequency 1 plus 0.5. Okay. Sorry, good. So we have two arrays now. Now we have midpoints and relative frequency. Okay. So you have midpoints, which is this one, right? And we have relative frequency, which is this one. Now, if I plot a bar plot like this, right, we want to pass two arrays, which is the first one is the midpoints and the second one is the relative frequencies. Now, if we pass it through this bar plot, let's see what happens. So in the first array is the midpoints. The second array is relative frequency. First array is midpoints and okay, so it gives an error. Can anyone guess why is it giving an error? Does it say anything? It doesn't say anything. Okay, it says shape mismatch, a dimensional mismatch. Why is there a dimensional mismatch? I actually told about this 5 minutes ago. So dimension of midpoints and dimension of relative frequency do not match. Does anyone remember what is the dimensional mismatch happening? Okay, so let me actually do this. So length of relative frequency, that is 10, right? And midpoints, I described 5 minutes ago that it's actually 11 because midpoints is coming from shifting this endpoints of the classes, right? Which has 11 data points, right? So obviously this won't match, right? This won't match the dimension, and therefore you are going to get an error. And when we are programming for doing this, getting this dimensional mismatch, this is if you could not figure out the dimension, it's a headache actually. So what do we need to do? We need to get rid of this last one, right? So last one is not a midpoint of any class. Actually, the classes were from 1 to 2, 2 to 3, 3 to 4, 4 to 5, and so on. The midpoints are 1.5, 2.5, 3.5, so on. So the last class midpoint is 10.5. So just erase this 11.5 from the midpoints, okay? So erase that. I think there is this np delete. What is that? What is this? This 11th entry, which has index 10. Okay, so let me see if it works. Excuse me. It works. So np delete midpoints, it gives you a new array where the last entry, which is the 10th index entry, actually that is the 11th entry, but index is 10. Is deleted. Actually, we need to store it because if I call midpoints again, you are not going to get this entry. You still have this entry, so we need to store it back, right, back to the midpoints. So let's store that out. Okay. Now, if we run this command, which is this one, the bar plot. Okay, so this should give me the relative frequency histogram, and that's how we get it. Okay, so the for is it
Sir, can you share this code?
I'm not sure how to do that. So like, should I copy it and paste it somewhere? The whole command line. I don't know if it's possible.
Sir, otherwise you can do, sir, that to save this and you can share the file.
Okay, let's see if I can save it. Okay, I will figure it out how to save this. Okay.
Top left.
Sir, here, sir, you can go the file section and then you can save.
But save doesn't it save only this script actually? I think it saves this script here, not the not this console. Let me try, but anyway. So if I try to save this,
So you can export as text and then
let me see. But I think it's all about this part for. Okay, I'll do that at the end of the class. Okay, so I'll figure it out.
Sir, right click in the empty space.
Yes, save as
HTML.
Right. Save as HTML. Okay. But it saves as HTML, not as a. But anyway, let me try this sample code. Okay. Let's save this. Okay, inline. All right. So let's see if it worked.
Sir, please share with us and we can check that if it is working.
Yeah, let me actually double check. So I have this sample code here, and so this is HTML file by default to open with your browser. Okay, so this gives me. All right, this is HTML code. But if I open it in a browser, let's see how it looks like. Okay, it looks fine, I think. For in a browser, it looks fine. Okay.
Sir, could you please share with us so that we can check that one once? If it is working with us.
Right now?
If you share, then we can understand that it is working, or then you can send the full one.
So let me actually, what do I put this in that?
Sir, in the MS Team chat box.
MS Team, right? Yes. Okay, so MS Team chat box. Let's add this file. Okay, so I put it in the MS Team chat box. So if you double click on that, this is an HTML file. So by default, this will open with a browser. Okay. Let me do this. Okay, so let's save that. And actually, there is a way to save image directly from Python, so I'm not just using it. Okay, so right, so let's insert it here. All right. Okay, fine. So this is all about the relative frequency. I mean, the theory is very simple. You just need to divide the frequencies by the total frequency and draw a bar plot. But I just wanted to give a demonstration with this coding. And for other programs, I think for MATLAB and R, they may have inbuilt commands too. I need to check. Okay, the next one is about pie chart. So okay, so how do we do this? So usually, um, this is used to show comparison different categories. Of actually a comparison of numerical data coming from different categories. So and here is an example. Actually, I think I did that once before. So you'd like to see the car sales in India by different brands. And yeah, this is the one I had opened before. Okay, so we get some we get a data something like this. You can see my screen, right? So like here in the financial year 19, which is last year, and it gives you different brands like Maruti and how many cars they have sold in the last year. If you want to compare these, so I can use something called pie chart. Actually, you see that they have already used pie chart, but we can generate that. Okay, so let me input this data. We have brands. Actually, let me see if I can copy this. Is it going to work? Most likely not. It looks very bad. Anyway. Okay. So I'm just going to put it in my second screen and.
Sir, you can do one thing that to take a snapshot and you can paste here.
Yes, that is also one thing. So let us try to do that. Okay. So it saved somewhere. Okay, here. Okay, good idea. So let's input here. All right, great. Okay. Now I'm going to type this and do in the Python format so that I can use it there. So the brands here. Okay, so brands here. Okay, so we have Maruti. And Hyundai. Mahindra. Tata. Honda. Toyota. Ford. Renault. Nissan. Volkswagen. And there is also our step. And so these are the brands and the sales figure. Excuse me. So I'm doing, let's say, the financial year 19, which is the last year. Okay, so 172926 545243 254351 231512 1837718 787. Okay, is that 1500525 92937 79 654 36 525 34 859 38 217. Okay, so let's input that. And the sales figure. First of all, let us check the dimension is correct. 11 and sales. Fine, good. Now there is a way to okay, before drawing the pie chart. Actually, let me describe what this is. Actually, I you know what? I think I should input sales as an array function. So before doing pie chart, so let me show what a pie chart is to draw a pie chart. We need to find relative frequencies of each category. And the second step I will describe. But let's first do this one. So relative frequency of each category, right? So how do you do this? So let's call like the relative sales, which is sales divided by sum of sales. So if I call this, you will see the relative frequency of each category. Basically, these are the market shares of different brands in the last financial year of passenger vehicle. So let's copy that and put it here. So relative sales. Okay. Now, what we need to do in the second step, we need to so basically, okay, what is a pie chart? Pie chart is, I think we have already seen this, in news and many other places before. But essentially, what you do, you draw a circle, okay, and you assign a slice to each different brand, okay, and size of the slice is essentially the proportional to this relative frequency, okay. So basically, angle of each slice is proportional to the relative frequency or frequency of each category. Okay. So if you want to find so angles, right? So the angles are going to be basically the formula would be the relative frequency. Times 360, right? So because if you add up everything, you get 1, and these are the proportion of 360 degree, and that angle will be assigned to each of the category. So if I do it here, okay, so what are the angles? Angles are going to be the relative sales times 360. So angles are that. A different company will get different angles from different slice from this pie chart. Okay. Now, if you're doing it by pen and paper, so using this data, you can actually create a pie chart because you have these angles, right? And you just draw angles, and you will get the pie chart. But actually, in Python, there is I think an inbuilt command which is pnt.py. Yes, so this will give you the pie chart from a given data. So this X is basically the data set. So we pass the X as the data. So X is the data set which is passed through. And labels. Okay, so these labels are the brand names, the labels that we have here. So these are the labels. So in our case, labels are the brands. And there is also an optional command which is auto percentage and so on. Actually, so let me tell you something about general thing about Python. So what happens here? If I this plt.py, which is actually the function matplot lib.pyplot, recall this whole thing was renamed as plt, so that's why it is calling the function this one. This function takes these many arguments, but you don't have to supply these many arguments. If I supply this single argument, this will work. If you supply additional argument, the more arguments you supply, more customization you can make, but you don't have to supply all the arguments. Okay. So, for example, if I just simply supply the first argument, which is plt.py and the sales figure, okay, this should give me a pie chart. Yeah, that gave me a pie chart. Okay. So this sales figure is our data set. Where is that? Yeah, this sales is the data set. Now, if I supply more arguments, like if I also supply the labels, labels are stored as this, as that brands, right? So if I supply the labels, it will put the labels there. Labels equal to brands. I think I had. Okay, so it also put the labels here, which is Maruti, Hyundai, Mahindra, and so on. You can see Maruti had actually more than 50% of market share. If you look at the angles, actually it is refilled there. So the angle for Maruti is 184, which is more than 180, and that's more than half. Right. All right. You can also create a percentage of each share, each of these slice, using this auxiliary command, which is auto percentage. So if I supply that argument here, so let's write auto PCT. Actually, there are many ways to customize this autoplicity. I don't know all the customizations, but I want to do, let's say, like up to 2 decimal places, so 1.2 floating point. I think this should work. Okay, so that worked. So percentage given for each category, like the Maruti has 51.22%, then 16%, and so for different categories of different percentage, and you get that. So I mean, if you are interested, you can search in Google, read the whole documentation, and there are many other things that you can do actually. With this, you can make it like 3D looking, like you can, if you want to slice out something. So so let me actually call this thing PLT dot. Okay, so this function has many auxiliary inputs. I think there is one input called explode. So explode means, I think, if you want to slice out a particular category, so this will this will show highlighted. So I think let's see if it works. Suppose I want to slice out the first one, which is the 51 point, or maybe the second one. Okay, the Hyundai one. So I think I have to give the amount which I want to slice out. So 0, 0, 0, 0, 0, 0. How many zeros should I give? This has to be total 11 categories, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, 2 more zeros. So let's see what's export is equal to export, right? Sorry. Okay, what's the dimension of export? Do I need to put it as an array or something like tuple? I'm not sure why this is not working, but
what is this explode?
so actually what it does is, so this pie chart, a uniform pie chart, but if you want to slice out a pie, you see the pictures, like, in newses or somewhere. So what it does, what it's supposed to do is something like this. And that particular category will be shown outside, like it's sliced out, that way. Okay. So this
So
is
why
what
you
it
are
does. What?
Sir, why you are providing 0.1 there for the second?
Basically, how
0.1.
yeah. So basically, how much you want to put it outside. Okay. So 0 means all are intact. Okay. 0 means all are intact, and then you give a number between 0 and 1. That will give you how much you want to push it outside. Okay. And which category you want to push outside. So basically, I am supplying 0.1 for the second category. I wanted to push this Hyundai one a little bit outside. But I don't know why this is not working. Anyway, so let me actually
Explode will be an array.
Yeah, actually, let me try that. So if it is an array, let's see. So one final time, let's try if this is working. No, this is not working. Yeah, anyway, I need to see the exact documentation, how it works. Okay, so let me save this one and import it just to save time. Okay. All right. And also, actually, I would like to tell a few more things. So, in the last lecture and this lecture, I have been using this library, which is matplot live.pyplot for plotting things, right? For basic plotting, actually. There are other libraries in Python which are also used for nicer plotting. I think one is called Seaborn or Seabeans, something like that. So let me actually check.
Sir,
Yes.
before you have missed one comma between explode and label, sir.
Oh, thanks for pointing that out. See? Yes, that worked, right? Yeah, so this one, the Hyundai one is slashed out. Thanks for pointing this out. Okay. Import that. Okay. Yes, actually, there is another library which is called Seaborn. Okay. This is a beautiful library, and you can do many other beautiful things with this thing for data visualization and plotting many color of suns and so on. So let me make a comment of that. So this was, I think, all right. Yeah. Can also be used for data visualization. Also, pie chart and everything using this library Seaborn. Anyway, so I think okay. So this. So let me take 5 minutes break, and there is no survey for the part one. There is a survey in the part two of today's lecture, and I'll be back after 5 minutes. Okay. All right, so let's begin. Am I audible now?
Yes, sir.
Okay. All right, so for the part 2 of today's lecture, I'll do some basic calculation with the data set, so which sample mean, median, actually mean, and then variance, standard deviation. Okay, the first one is sample mean. So it's a very easy concept. This is simple average. So we have, suppose you have a sample, which is which contains n data points, say x1, x2, xn. Then the sample mean is simply okay, so which is often denoted by x bar. That is simply 1 over n summation of xi. Okay. Very basic concept. There is no confusion there. But along the same line, tell you which is sample mean. Okay, so what's that? Suppose we have two samples. Okay, so sample 1. So sample 1. Which contains these data points x1, x2 up to xn. and someone else also have done the same sampling. Actually, someone else also have done the sampling from the population. Their sample is like Y1, Y2 up to Ym. Okay. Basically, my point is that notice the size of the sample. This the first sample has size n, second sample has size m. Now, the sample made from the first sample, which is x bar, that is simply 1 over n summation xi, I is equal to 1 to n. And sample made from the second sample is y bar, which is 1 over m summation yi, I is equal to 1 to m. Okay. Sample made would like to calculate the mean from the combined sample. Okay. Suppose you mix all those data and you want to compute the sample mean from there. That is obviously going to be so that sample mean, combined sample mean. So let's denote it by, how do I denote? Say like a bar. So this is going to be 1 over m plus n. Have all the data, which is summation yi. Okay, let me first write xi. Doesn't matter though. Xi I is equal to 1 to n plus summation yi I is equal to 1 to m. Okay. So this is the answer for the combined sample mean. But if you want to write this combined sample mean in terms of the sample means of the sample 1 and sample 2, essentially what I want to do, I want to write this a bar in terms of this x bar and y bar. X bar and y bar are sample means from sample 1 and sample 2. The way you would do it is also very easy. So that is 1 over n plus n. Okay, now if you look at the expression here, so this summation xi, right? So summation xi is n times x bar. So if you put that n on the other side, you get n times x bar. So you get n x bar. And similarly, summation of yi is m times y bar. Okay. So that's it. So this is the weighted sample mean. If you want to write it in a little bit different way, which is n over m plus n x bar plus m over n plus n y bar. Now, so what did I say? Weighted sample means. Essentially, you see that this m over m plus n and n over m plus n. These are like the weights. Okay. Weights to this x bar and y bar. Essentially, the point is that if so sample 1 size n, okay, so one size is much higher than m, right? Then from the above expression, you see that then this n over m plus n is very close to 1, while excuse me, m over n plus n is close to 0, right? This quantity A bar, right? That A bar that I was talking about, which is the combined sample mean. A bar is given more weight or like importance to the sample mean from a larger sample, and which is also intuitively fine, right? So if X bar is obtained from a larger sample, then you can guess X bar is a more accurate estimate than Y bar if Y bar is obtained from a smaller sample. And whenever computing this combined sample mean, you should give more weight to the sample mean which is obtained from the large, that is more accurate than the sample mean obtained from the smaller sample. Okay, so this is weighted sample mean, and it's a very easy concept. Okay, so what is the next thing that I want to do? I want to do sample variance, right? All right. Sample variance is defined by so you have a sample again, say the same thing, say like x1, x2, xn. Then we define sample variance, which is little s, excuse me, little s square, that is 1 over n minus 1 summation xi minus x bar whole square. Okay, one important thing I would like to highlight here, it is 1 over n minus 1, it's not 1 over n. So in a sample when you have 1 over n, but for sample variance it is defined by 1 over n minus 1 and xi minus x bar whole square. If you recall that, I know the actual variance formulas from probability theory classes, that variance of x is equal to expectation of, so expectation is essentially this average sum. Okay, expectation of x minus expectation x whole square, right? Essentially that's what we're doing here. So this expectation x is like x bar, x is the random variable which is xi, and outside expectation is again average sum, like that. And if you recall, there is an alternative formula which is expectation of x square minus expectation of x whole square. Okay. So same thing will also be true here. This will be 1 over n minus 1. And if you understood how this was proved, how that thing was proved, you can prove this part also. So this is going to be summation xi square I is equal to 1 to n minus n times square. Okay, so this could be an exercise to prove that the summation of y is equal to 1 to n xi minus x bar whole square is summation xi square minus n times x bar square. Okay, so this is how you can calculate sample variance. And sample standard deviation is simply the square root. Okay? So sample standard deviation, it is simply the square root of sample variance, right? So you just write this little s, that is square root of 1 over n minus 1 summation I is equal to 1 up to n xi minus x bar square. Okay. Just for the sake of completeness, let me just do that with some data. So let's have some data which is create some normal distribution data points, say like 62 data points, right? Actually, let's round that up. So I'm going to do round that up to 2 decimal places. So this new version of A is the same data rounded up of 2 decimal places. So let me write a comment here. This A dot round data decimal rounds up the data up to that specified decimal places. So this is my A. Let's do that. Okay. Now the main, right? So simply, what is the length of A? We can put it there. So sum A divided by length of A. So that is excuse me. That is the main. So main is this quantity. To calculate the variance, what do I do? So I'm going to use this alternative formula, which is 1 over n minus 1 and summation xi square minus n times x bar square. So let's store that n with this variable. So n is equal to length of that data set size, which is 62. And now what do we want to do next? Okay, so we want to calculate sum of xi square. Okay, so sum square, how do you do that? Actually, in Python, if you use this command that data start 2, doesn't have to be 2, maybe like any number, so like d, right, or like k. This returns kth power of each value from this data set. Okay. So for example, if I do A, so A is my data set. If I do A start 2, I'm going to get squares of each value. Okay, so let's store that somewhere. Okay, I don't need to store it. So let's just do the sum square. Sum square is equal to sum of these squares of each entries. Okay. So that's the answer for sum of the squares, right? What's that? Okay. So essentially here we have a summation of xi square is equal to 1 to n, that is equal to okay, so all right. Now we subtract n x bar square and 1 over n minus 1. Okay, so let's do that in a single step. So the variance is going to be this sum square minus n times mean, okay, square, right, n times mean, divided by n minus 1. Okay, so that's the variance. The sample variance is going to be this one. Okay. Sample standardization. Okay, so all right. So this is a very simple thing about sample variance and mean, etc. The next thing that I wanted to do is median. Okay, so before median, actually, let me do something called percentile. So what is a percentile? This is defined like this: pth percentile data set is the okay. So actually, it's a numerical value. Let's call this a value v, okay, such that percent of data points are smaller than v, and rest of the data points, which is 100 minus p% of the data points are larger than v. Okay, so for example, in previous data set, if you want to find let's say, I don't know, like 30th percentile of the data set, right? So example, suppose we'd like to find the 30th percentile of the F4 data set, right? So which means that we would like to figure out a value such that 30% of the data points are less than or equal to, actually, let me write this. Data points are less than or equal to 30% of the data points are less than or equal to v, and 70% are bigger than v. So in the okay, so what is the answer? The f of data set size is equal to 62. So what is the 30% of 62? 30% of 62. So that is 18.6. okay, is 18.6, right? Essentially, what we want to do, we would like to find a value v such that now here's the trick. So such that 18.6 many data point values are less than v, right? But 18.6 is not an integer, so we would say like 19 many. Okay? 19 many data points are less than or excuse me, less than or equal to v. Okay, so it is a fraction. So we just take 19 data points which are less than or equal to v. So essentially, the v is going to be the answer that so v is so 30th percentile is the 19th value. Okay, 19th value of the given. Actually, a 19th, I would say 19th smallest value given data set.
Sir, so could you please explain that about data size equal to 62.30% of 62 is 18.6.
Data size is 62, right? So this A that we had, so actually let me see. So this A is this data set we have, and length of A was 62, right? And 30% of 62, so which is 62 times 30 over 100. That is 18.6, right? So that is 18.6, that is clear. But is that your question, or you are asking why this is 19 many? Hello?
Hello.
Yes. So isn't okay. So we want to find a point where. So okay, here's the thing. Let me actually draw a picture. Probably it's better to visualize. Okay, so here is the whole data set, right? So it is in the increasing order, right? And here is the point v. Here is the point of v. Okay, and we want on the left side, we want these many data points. 18.6 many data points on the left side. Okay. So how could you have 18.6 many data points on the left side? So essentially, this has to be the 19th smallest one, right? 19th value. Is that fine, or I need to explain something else somewhere? Who was asking that? Okay, so to do this, right? So to do this, first step is we need to. Excuse me. We need to organize the data set in and I think there is a command in Python which is if you type this data dot sort, this will return the data set in increasing order. Okay, let me try that. So my data is A. If I write A dot sort, okay, now A is organized in increasing order. Okay, so if you want, I can take a copy of that. The second step is that we figure out the 19th value, and which can be obtained by index is going to be 18. So my A is this, right? Which can be obtained by type, because the indexing starts from 0, as I keep saying, right? So this first value is the 0th value, then this is 1th value, this is second, and so on. So 19th value is actually A18. So if I write A18, this is 0.46. Which one is the 0.46? Okay, here it is. So this is the 0.46. That is the 19th value, and this is the 30th percentile. So is it the 19th value? Let's say 1, 2, 3, 4, 5, 6, 7. Okay, excuse me. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes, 9 and 18th, and this is 19th value, right? Which is negative 0.46. So the answer is this negative 0.46. That is the 30% quantile. So that is the 30 percentile actually. That is the 30th percentile of the data set. 30th percentile of the data set is negative 0.46, which means that 30% of the data is below negative 0.46 and 70% is above negative 0.46. Is this percentile business clear? Okay, along the same line, let me introduce this thing called quartile. Okay. So what are quartiles? These are specific percentiles. The first, second, and third quartiles of a data set are respectively 25, 50, and 75th percentiles of the data set. So first quarter, a quarter means quarter, which is 25, right? So first quarter is 25, second quarter is 50, third quarter is 75. So first quarter means you want to figure out a value where 1/4 of data points are below that value and 3/4 are above that value. That is first quartile. Second quartile is just at the middle, and third is the 75. So the second quartile is the median. So median is essentially the value where half of the data points are below that value and half of the data points are above that value. And I would like to add 2 more points to this. If the data set size, which is n, is odd, right? Then the median is simply the middle value, which is so if it is odd, then the middle value is given by n+1 over 2 data point. right? So for example, if a data set is of size, let's say like 11, right? Then the middle value or the median, okay, so excuse me, then the median is the so what is the middle of 11? So it's 6th, right? 6th smallest value. Okay. So if you draw a picture, that will be again more clear. That so here is your data set. The first value is 11th value. What is the exact middle one? Exact middle one is 6th, right? So there are 5. So if you write 6, there are 5 values on the left, and there are 5 values on the right. And 5 plus 10, and 6th one, total 11 data points. So for what data set size, this is not a problem. But for even data set size, you just take an average of 2 middle values. Okay. The second one is that if the data set size n, excuse me, is even, then there are 2 middle values, right? Namely the n over 12th value, n over 12, and n over 2 plus 1, the second one, next one value. We simply take the average of those 2 digits. Okay. So for example, if the data set size is, let's select 12, right? Then the middle points are middle points are 6th. Okay, actually, let me see. Write this. Then both 6th and 7th values are the middle points. Okay, and median is going to be equal to the 6th value plus the 7th value divided by 2. Okay. So in the previous example, we have 62, isn't right? Many. So therefore, the median, right? Median is going to so there are 2 middle points. One is 31st plus 32nd. Those values, so 31st value, 32nd value divided by 2. If you run the Python command would be this a. So 31st value has index 30 actually, as I keep saying, and 32nd value has index 31 divided by 2. So this will give me the median. So for example here, so this is my a. The 31st value is indexed by 30. So this is actually, excuse me, this returns the 31st value. Okay, and a 31, right? This will return the 32nd value. So the median is going to be A30 plus A31 divided by 2, right? Which is 0.135. So this is 0.135. Right. So that's about median. If you have any question about median, you may ask. Okay. I forgot something. So along the same line, actually, let me do something called box plot. Okay. It's a very simple thing. It is very widely used. Many places, especially in the stock market price indexes. So what is a box plot? Instead of writing, I think it's better to just draw it. So you have a whole data set, and suppose this is the lowest minimum. So minimum, that's the maximum. Okay, and then you identify 3 quarters. This is the first quarter, which is the 25th percent, right? And second quarter, which is 50. That's also actually the median. And 75th quarter, 75th percentile, which is the third quarter. And then what you do, you just draw a box. Okay, that's it. You just draw a box from first to third quarter. Okay, and you sometimes put a bar to denote the median. Okay, so this is what I call this is what they call a box plot. Python has actually built-in comment. Let me see, box plot. Yes. So if I box plot this data A, this is what I get. So it's actually giving me in a vertical plot, but that's fine. So let's insert it here. All right. So it is this plot program is giving me a vertical plot, but I think Seaborn gives you a horizontal plot. So essentially, as I was saying, this point is this point is the 25th. Sorry, this point is the 75th percentile. This is the median. And that's the 25th percentile, or the first quarter. Okay. So you get the box plot like that. All right. Okay. And then now the last thing that I'd like to do is mode, which is also a very simple concept. Okay. Mode of a data set is the value which occurs most frequently. For example, let's go back to the previous day's data set actually. This one. Let's call it B because I already have A in the now, if you do a histogram, actually, you can figure this out. So, which value occurs most frequently? So, from 1 to 2, 1, 2 to 3, only 2, 3 to 4 is only 3. Actually, let's copy that and paste it here. So the highest value is this 12 and 12. And I think, as you can see, that this 5 occurs 12 times and 6 occurs 12 times. Okay. 1, 2 to 3, 2, 3 to 4, 3, 4 to 5, 7, 5 to 6, 12, and 6 to 7. Okay. So there are 2 more cells, which are 5 and 6. There are which are 5 and 6 because those are the values which occur most frequently. And finally, I'd like to say one more thing. So the definition of mode, which I said that is the value which occurs most frequently, but the above definition of mode does not work well with continuous type dataset. So, for example, the dataset which are generated by from continuous distributions, like from normal, exponential, right? So these kind of distributions, or if you're taking a data set which contains the height or weights of people. So these are all continuous type data sets, right? Because heights do not have to be a specific integer. You can have or weights, you can have like 67 kg or 67.3, 67.31, 67.29. I mean, all possible numbers are there, right? So these are continuous type data sets, right? So if you have continuous type data set, then what happens there? That, as you know very well, that probability that a continuous random variable takes a particular value is 0. So my point is that in those cases, like each value occurs at most once, I think. So even if you look at this data set, right, I don't think there is any value which is occurring twice. So each value is occurring at most once, I think. So in those kind of cases, value occurs at most once, usually. Right. So how do you figure out mode there? Right? Because each value is occurring only once. The way you figure out mode is first you draw a histogram, okay, and then identify the class, or which is the sum interval. Having highest height. Okay, in that kind of those kind of data sets, you identify the class which has the highest height, and we say that model class is that highest height class. Okay, so for example, with this data set that I have, if I plot histogram here, actually not this one, but histogram of this one, A. Okay. And let me also copy these numbers. Okay, so the highest frequency here is happening with this one, which is 14, right? And that class corresponds to which one? Let's say, so 3 is this one, 7 is this one, sorry, 3, 5, 7, 11, 6, 14, okay, this one. So this is the model class. So notice that in this continuous type, we are talking about a model class, not a particular value as mode. So we say that this subinterval contains most values, and that class is the model class. That's what we say. Okay, so I guess this is a good time to stop. And so there will be a quiz tomorrow. As I said, that this Monday is a holiday, so there is a quiz tomorrow, and obviously tomorrow is going to be a discussion session. So I think the survey form is already up online, and once you're done with the survey, you may leave the session.